of our project is spatial visualization of flooded areas and their effects on public infrastructure in the Valencian community. Let's talk about a little introduction, that is the first part of our video, about the context and importance of the problem, because the Valencian community, located on the eastern coast of Spain, has historically been susceptible to extreme weather events such as heavy storms and flooding. In fact, in particular, the phenomenon known as DANA, isolated depression at high levels, which impacted the region in 2024, caused severe disruption across various areas, affecting both the population and public infrastructure. The flooded zones included urban areas, health centers, schools, transport stations, and other critical facilities essential for the community's functioning. The visualization of geospatial data has become a fundamental tool for understanding and communicating the effects of such natural events. The creation of interactive maps and graphics allows complex information to be presented clearly and in a very accessible way, facilitating decision-making of both governmental and societal levels. Analyzing flooded areas and identifying vulnerable infrastructure, in fact, are key steps toward enhancing resilience and improving the response capacity in the face of future natural disasters. The main objective of this study was to develop an interactive visualization of data related to the area affected by the DANA in the Valencian community, with a particular focus on public infrastructure such as hospitals, educational centers, train stations, and airports. The aims of the analysis are to identify and map the areas flooded during the 2024 event, to assess the impact of the flooding on key regional infrastructure, to provide an interactive visual tool that allows users to explore the data and understand the most vulnerable areas, and at the end, to analyze trends and patterns related to the location of the affected infrastructure and their resilience capacity. Through the integration of various geospatial data and their visual representation, this project aims to provide a valuable tool for future urban planning and risk management decisions in the Valencian community. Since the main objective of the project is to analyze the extent of the damage caused by the DANA to public interest facilities, we focused on collecting information on relevant nodes such as health centers, educational institutions, metro and train stations, airports, roads, among others. So to do this, we take the data from various official platforms such as Valencia Open Data and Datos. These portals provide updated geographic information that allowed us to locate the necessary infrastructure for the study, and the DANA flood footprint was obtained as a raster, and used this layer in spatial analysis were converted into a vector polygon layer using the raster pixels to polygon tool. And this conversion allowed us to represent the affected area in a very precisely way, with each polygon indicating the water height in centimeters. The entire set of polygons in this layer represents the total area affected by flooding. We used a little library in R for combining layers and interactive tools. The result is an interactive, user-friendly, visually appealing viewer for exploring diverse geospatial layers. The focus was on clarity and simplicity without sacrificing analytical power. Our map is very easy to use, so you can choose the kind of map you want to see, and here we can find some more specific information about the main municipalities of Valencia, about the area of the flooded during the 2024 DANA. More information also about the educational centers that are located near or within flooded zones, and then also about hospitals in red, and train station and airport station in green and in purple. Understanding of the results and the visualization of geospatial information, various visual resources such as charts and interactive maps, as we can see before, were used. These tools allow the user to intuitively explore the data and gain a clear view of the spatial distribution of the areas affected by the 2024 data. The map highlights the affected geographical areas with municipalities shaded in different tones of blue. You can see it from here. Darker areas experience more intense flooding than the lighter ones, and the most affected municipalities are concentrated around major urban areas like Valencia. However, rural and perimetral zones were also impacted. Critical infrastructure in high-risk areas such as hospitals and schools showed high vulnerability, emphasizing the need for more effective protection measures in these zones. Public transport infrastructure was also severely impacted in the areas near waterways, highlighting the importance of flood risk assessments when planning new infrastructure. And by the end, the less affected areas offer an opportunity for better land use planning and more resistant infrastructure development in the future. Our analysis, we use some bar charts. From here you can choose which kind of data you want to see. So the data that's referring to the airports, to the educational centers, to the train station, but also the data that refers to the hospitals. And here we have the legend of the axis. In every kind of data, by the way, the red bars are indicated the most affected areas and the blue bars the unaffected one or the less affected. That the results obtained in this study on the impact of the data in 2024 in the Valencian community have confirmed the importance of interactive visualization tools and the geospatial analysis for understanding the effects of natural phenomena such as flooding. Our initial objectives had been successfully achieved with the combination of interactive maps and charts. We can do in fact a detailed analysis of the spatial distribution of flooding and also about its relationship with critical infrastructure such as hospitals, schools, but also the transport station as we saw. And the implication of the findings are very important because hospitals and schools located near rivers are, as we can see from these maps, from those maps, and other flood-prone areas are very vulnerable. And this underscores the need to reinforce the protection of critical infrastructure and to reconsider the location of new public facilities to reduce their exposure to future natural disasters. Also, the results highlight the importance of improving transport infrastructure to ensure the continued operation of emergency and mobility systems during flood events. However, our study has also some limitation because the availability of accurate and complete geospatial data was one of the main constraints, potentially affecting the precision of the data analysis. But another limitation involved the complexity of spatial analysis itself, which at times presented technical challenges when integrating data from various sources and formats. Of course, future work could focus on improving predictive model to identify high-risk areas before events occur, or also implementing more advanced simulation tools to study other types of natural phenomena. It would be also valuable to explore how adaptation strategies and preventive measures can enhance the resilience of critical infrastructures to this kind of disasters.